Today, we are going to take the topic of global positioning system in communication. Global positioning system is basically a way of locating a receiver on the earth within its three-dimensional space, or maybe in the orbit of earth. So, in today's topic, global positioning system, the short form is GPS. What we are basically doing, we are finding out the position of a receiver, and this receiver position can be found out with the help of around 30 well spaced satellites. Now these 30 well spaced satellites, they form a constellation. Constellation can be thought of a ring around the earth. These constellations are further divided into 6 planes. Now, what happens? These satellites send the radio signals to the receiver to find out its location. The accuracy of location is from 100 meter to 10 meter. Earlier, this GPS system is followed by the US defense system, but now it is commercially also used around the earth. Now we are going to talk about the working of GPS system. I simplified into the steps. The first step is the GPS satellite is revolving around the earth and it broadcasts the radio signals out of it continuously. Now, in the next step, these signals are carrying the data. This data is passed from the aerial, it is decoded, and it is used by the GPS software. Now, this GPS software can in the first step, it can find out where the receiver is located. The location of the receiver is being able to find out with the help of the GPS software. And the second important thing is it is able to calculate the time that have been taken by the signal to travel from the satellite to the receiver. Now, these information the GPS software is receiving from different satellites, not only from single one. Different satellites are giving this information to the GPS software, and GPS software is utilizing all this information from the different satellites to find out the location of the receiver. Now we have talked that the GPS software, it is working on the information that is provided by the different satellites. Now, finding out these signals and utilizing the information to find out the position of the receiver is just similar the orienteering. According to orienteering, if suppose we want to find our location on the map, so we identify three positions on the map and draw 3 lines with respect to these position, and the triangle formed at the point of intersection will be the location. Similarly, the GPS software is also doing the same thing. Different signals of different satellites where they are getting intersected. At that very position, the position of the receiver can be thought about, it can be judged, or it can be estimated. Next, we are going to talk about the mapping part of GPS software. When we compare the GPS system or the softwares, which one will be doing it more efficiently? So the price of GPS software increases with the accuracy of the mapped data. It is but obvious the software that will be giving us the more accurate information, that will be having more number of satellites, better software working on it, and obviously the price will be more for the same. In any GPS system, these are the three major components that will be utilized. Among that, first is the space segment. In the space segment, it is consisting of the GPS satellites itself. The second one is a control segment. It is going to monitor the space segment, and it is one who is going to send the commands to the satellite. The next is the user segment. User segment is very bulky. It consists of earth-based GPS receivers composed of, it is having antenna, radio signal, display, data recording unit, etc. within it. So these are the three major components that will be helping for the GPS location, and these components will be working together to find out that location. Now, let us understand how this GPS system is doing all this positioning. It's a simple mathematical approach. What we are doing, first we are considering this as a earth. O is the center and RE is the radius of the earth. Now let S1, S2 and S3, these are the three satellites, for instance, we have taken. Now this S1 satellite, it is sending a signal, say at time T1, it has sent the signal. So this thing is being done by the first segment, that is the space segment. Now the ground receiver is going to receive the signals, let it be at time T2. Then the range measurement or the distance between that position to the satellite is, say, R1. It is given by, we are following the simple formula, speed is equal to distance upon time. And here distance can be taken as speed into time. So this is what is being taken here. This is the distance and the speed of the waves and the time taken by signal to travel from satellite to the receiver. Now, since these are the radio waves will move with the velocity of light. Here, c is the velocity of light waves. That is the radio waves that we have taken. It is equal to the time taken. Now the time taken is the difference of T2 and T1. So we are getting R1 by putting the values. This we have received. This T2 minus T1 can be noted down, and we are knowing the velocity of the radio waves that are being sent. By multiplying them, we will get the R1. Similarly, for satellite S2, let R2 be the range. R2 is equal to C T3 minus T4, where T3 here is the time that has been sent from the satellite to the signal. It is sending at time T3, and at time T4 the ground receiver is receiving it. Similarly, we can find out the range R3. Knowing these values R1, R2 and R3, we can draw the spheres. Knowing R1, R2 and R3 spheres of radius R1, R2 and R3 can be drawn. Now, at the intersection of the point where these spheres will intersect, that will give us the position of the receiver. Here you can see when these are the arcs of the radius R1, R2 and R3, they all are intersecting, say, at position P. So the P is the position of the receiver. The point of intersection of the spheres will give the position receiver. So this is how the GPS system find the position of a receiver.